This is more of your skill. I didn't play.
Okay, would you guys give her two?
Three.
Okay, would you guys give two actually? Okay, I got two right, mine is X over, okay, mine is 200 and one over two. Teddy, you can add that pen.
I did 2x over 12.
And this is just actually homework, and I know how to do it. And the amount of times you've not done it, and said, boy, no, you do it, it's fine.
Yeah, I didn't do it.
I do it in the soccer.
Then when you're taking the meets, the
But I did it.
doctor gay. Yeah, the doctor.
Okay, I just heard something like that. And he had. No, I'm really not that.
It's not gonna be a part two, be a whole different story.
Letting literally be.
Yeah. Like I glitter, but I don't. And there's
But then literally the other
So
side.
like
But like glitter coming out of your eye, like that would feel like.
I can imagine.
okay, but it doesn't matter.
That's the usual
Party.
It's called star.
Like I'm really excited about it.
I have a very important question.
Yes, it's called.
Which one are you gonna go with? I'm personally going with sneezing and confetti. These other two are just not. They're not.
You'll find breakfast. I think sweat glitter.
No, but then you're gonna look like sweat stains. But like,
But then you're gonna.
This is glitter.
No, well, yeah. What
All right, so where's Winston and Caden?
Hayden texted me
Like
to get along,
glitter.
right?
White glitter, tried glitter.
All right, so
So
Dude,
you're so dumb.
Bro, I didn't even know I had that. I thought you get that when you get it in school.
No.
okay, this question I'm sorry, Mike.
You did your stars. Bebe, might not make you a bebe.
no.
Guys, let's go over the answers. Yeah, we were.
Okay, so for the FRQ, a lot of you guys didn't do it. I really think you should have done it because it's actually a very good question. I stole this worksheet from other teacher because I was tutoring other people, and then I was like, "Oh, this looks like a question." So, so I stole it and I posted. But it's a good review question of your let's say FTC and also like rearrangement of the things. So I got for A is does not exist because it's not continuous. I got for AI, which is I got 16 because I write out integration from -3 to 4. So they didn't want you to take integration of that because on the bottom it did already tell you integration from -3 to 1 g of x is equal to -4.8. And from -3 to 4 g of x is equal to 11.2. Where's Lee? Where's Lee? He's like one person I have to worry about most. Now, there are a few, but he's probably worse right now. Yes.
Why is it wait, number wait, A is D and E?
It does not exist because it's not not continuous. So it's not continuous, it's not integratable.
That's what I thought, but ChatGPT was like, no, it is.
No, it's not integral. You have to be well, ChatGPT is not gonna be able to tell like certain
Yeah, you have
things,
really
but
bad graphs.
so I is gonna be 16 because that just write out an integral. And you should get 16. Now for the II is I break up to 2 integral, I take out a 2 outside and I take out a 4 outside. And I find out the integral for I already don't know -1 to 4 is 16, so I've changed it to 32. -4 times -1 is equal to 36. And then I go ahead and evaluate it. That's 36. C, I got B is equal to 4. I don't know if you got that, but I break them up, even like integration of f of x plus integration of b, because that's a piecewise function. So a piecewise function from the left side of -1 is going to be g of x. From the right side of -1 is going to be f of x plus b. So I break them all up, I write out, and I got b equal to 4. How many of you guys got b equal to 4? Very nice. No, you didn't do it.
I'm joking.
Yeah. So Samuel, do you know how to get that?
I like looking at it.
I break to pieces, and I got integration of b. Integration of b is bx. So I'm gonna plug in 4 and -1. They subtract each other, so it'll be 4b minus -b, and that will give you 5b equal to 20. It's actually a very cool question. Whoever come up with this question is pretty good math. Like yesterday, I had to like crash out. Like you know how Ollie like to use Ollie and Kench use the Brian Passwater worksheet. And I had to like I had to crash out because I had to tutor somebody that on Dr. Philip. Oh, by the way, Dr. Philip had a big fight yesterday. I don't know if you guys hear that.
Yeah, video.
No, you probably would just ask your friend on Dr. Phillips. They had like 20 people brought in the lounge.
They had what?
Yeah, and then they like stop the lunch.
Did you?
Does this fight in the school like lunch?
Yeah.
But it's not brawl like 20 people brawl, right?
Yeah, there was a fire. You know the area that was the path
Oh,
behind the
yeah.
parking lot that goes to like Walmart in that area?
It's 2 times
Someone,
engine.
I don't know what happened, but someone set it on fire, and there was a bunch of they had to call the fire department.
Wait, what?
You know the area like behind the parking lot that goes to the Walmart area? It's like a path. Yeah, that there was something got set on fire over there.
You're changing it.
What?
Yeah,
Like yesterday or
Oh my god, my friend's the one that called it. They run like macro class and the one that called across and they she did it.
Oh, yeah? Yeah, I know from band.
All right, so I'll send it everybody. All right, so what we're gonna do is yeah, I don't know, like I feel like Dr. Phillips is worse in this school.
Way worse, bro.
Way worse.
We have a lot more like. I think.
I think this fight here is like pretty like isolated. It's not like it's like a couple people fighting, like 2 people facing each other. Not like nothing crazy. But I don't know. I could be wrong. How often do they have fight in lunchroom?
Honestly, this year it hasn't been.
One time this week.
Last year was crazy though.
Yeah.
But you're number 4. Did you get it?
I remember last year. I forgot what when it was.
It was like 3 days on that. 3 days back to back.
That's crazy. All right. So what we're gonna do is we're gonna talk about the integration of 1 over x. And the problem is integration of 1 over x is one of the question that does not follow power rule. Now remember the power rule, right? If I would use power rule, if today use power rule, then the power rule says x to the n, guys. Separate. Seriously. Dx. So integration of xn, the power rule is x to n plus 1 over n plus 1 plus c. But it does not work. So you will see that it does not work with integration of 1 over x dx. Why? I just try it. Integration of x to the -1 dx, and that's going to be x to the -1 plus 1 over -1 plus 1 plus c. That's going to be x0 over 0 plus c. So that part becomes undefined. So the power rule actually says n cannot equal to -1 because it doesn't work if it's a -1. So then you say, okay, well, what works then? But it turns out that we learned something yesterday or the day before, because if I take a derivative of natural log of x is equal to 1 over x, then that result with integration of 1 over x dx is equal to natural log of absolute value x plus c. Now, some people says, why is absolute value? Because you cannot natural log a negative value. You can only natural log a positive value. So the output has to be always positive. Does that make sense? So now if I take a derivative of natural log of u, now understand that u is still different than x. The u is still different than x because derivative of natural log of u is u prime over u. So that result with, well, if I have a du over u, that becomes natural log of u plus c, which is most of the time we're going to deal with this part because not all the time we just have 1 over x. We usually has 1 over u. And also make sure that you put in mind, if you have u equal to something, you must have a du. You have to have a du.
Can you zoom in?
Show me where.
Is that du over u?
Yeah, du over u. Or some people even call it like u prime over u. Right? So you see the relationship of numerator is the derivative of the denominator. Then usually it's 99% of the time it's going to be natural log. So therefore it's natural log of u plus c. Is that okay? Okay. So we're going to try a question, see what you do. So this one is not just x minus 1. This one is 1 over 4x minus 1. You must have a u and you must have a du. Right?
U is,
Larissa, what's u?
I have no idea. Maybe 4x minus 1.
Good choice. U usually inside parentheses. If you don't see it, there's a parenthesis here. And if you have this one's 4x minus 1, then du must be what? You always have to find du. Get used to the habit. This is muscle memory.
1,
What?
4.
4
Oh, 4, yeah.
dx.
But didn't, okay.
The derivative of 4x is 4. Derivative of 1 is 0. So it's 4 dx. Don't forget about dx. Because du over 4 equal to dx. Because not I can replace this dx, right?
Yeah.
So that's going to be 1 over u. And this is du over 4. And it's going to be 1 over 4 du over u. Which is something we know according to this. According to this, you say, oh yeah, that's just 1/4 natural log of u. There's more cool stuff later. Actually, tomorrow.
Hope so.
Is this okay? You can also find area of definite integral. So for example, I have this function here. And this function looks like this. And this function is y equal to x over x squared plus 1. And this is a 0 to 3. I want to find the area here. Well, how do I find area? I need to do what? How do I find this area? And I have the function. What are you supposed to do? Take an integral, but what kind of integral? Definite or indefinite integral? Definite, between 0 to 3, good job. Over x squared plus 1 dx. Now, this is something you can do, but only thing I will remind you of, please do u substitution. And when you do u substitution with definite integral, remind yourself, change the x bound to the u bound. Get used to change the x bound to the u bound and do it in terms of u bound. Because on AP exam, there's multiple choice question. There's 4 choice. If you just change the boundary, you can eliminate 2 of the choices. So instead of 1/4 chance, you already all of a sudden you got 1/2 the chance to get it right. Just use to change the boundaries. So this 3 and 0, hopefully you change the correct boundary, and then just do it in terms of u. Do not go back to x. Just do it in terms of u. You're gonna realize it's actually easy. Change the boundary. We did that before. Change the boundary. And I keep on reminding people do that. And then people says, oh, I can convert back to X. I'll make sure you do an X. Yes, you can. You're going to get the same answer. But that's not what AP will ask you, because they'll give you 4 choices. They'll say, which one's use substitution, which one's following. Yes. Caden?
What does it mean?
So that's fine. There's no dumb question here. This is the X value, right? This is 3 is the X value, right? This is 0 is the X value, right? So we talked about before when you're doing integration. When we're doing U substitution, wait, hold on a second. When we're doing U substitution, then this would convert to du and this will convert to in terms of u. Then the problem is this boundary is an x, so you have to convert back to x to plug in that. However, you can do it everything in terms of u, then just change the boundary from 3, which is the x, to the u bound. How do I do that? Because what is u here? What will be u here? And what will be the change in the new boundary is? Yeah, so it'll be 3 squared plus 1 is equal to 10. And this is 0 squared plus 1 is equal to 1. So this one, I will plug in new boundary and just do it in terms of u. And I'll show you they are the same answer. But I'm just telling you, AP exam only wants you to change the boundaries, especially MCQ. So get used to that. Oh, U substitution, change your boundary. Yes.
Plug it in for the u and the ln of u plus c.
No, you don't have plus c anymore because you have definite integral.
I know, I just meant like that formula.
Yeah.
So I'd get like 1/2 of, or 1/2 times ln of 10 minus ln of 1.
Yeah, you're absolutely right. That's the right answer.
Alright.
And natural log 1 is 0. You don't worry about it. Just ln of 10. Jacob also becomes smarter after I throw him on the ground. I should throw him on the ground earlier. Really? Oh yeah, that's true. Yeah, you're autofocus now. Your eyes like this big.
Yeah.
Right. You should see it in his eyes like this. Yes.
Plug in the boundary percent, like I got that LN equation, but what do we do with the boundary?
Okay, we're gonna show you. So we know u substitution is equal to x squared plus 1, right? Du is 2x dx. Don't forget a 2x dx. Du over 2x equal to dx, like this. So that's gonna be u, is that okay? The x, I'm gonna keep it there, du over 2x. The x cancel out. So that's gonna be 1/2 of du over u. Is that okay, Miranda?
Yeah.
Now I'm gonna change the boundary because we're gonna use the 10 and 1. Can I do it in terms of x and just make sure everything's x bound and x? Yes, you can. But AP exam wants you to change your boundary on multiple choice. So this one is going to be 1/2 of ln of absolute value between 10 to 1. So it'll be 1/2 of ln of 10 minus ln of 1. And ln of 1 is 0. And if you really want to be cute, you can say it's natural log of square root 10 if you really want. But they both have the same answers. So this answer is acceptable. This answer is acceptable. 10, no, not 10 over 2. ln of 10 over 2 is bad. Well, actually, you can. You can say ln of 10 over 2 like this, but you cannot say ln of 10 over 2 like this. There's a difference.
ln of 10.
Yeah, that's fine.
Not plus c.
No, because there is no c. So if you integrate, you have a upper bound and lower bound. The c will c from upper bound and c and lower bound is going to cancel out equally. So there's no c anymore. So when you do definite integral, there's no c.
Yeah, it's 1/2 ln of 10.
And what does it say on the right?
ln of 1 square root of 10, because that's 10 to the 1/2 power, which is square root. All right, I'm gonna give you a 3 question. The final answer is natural log of 1/2 natural log 10.
Yeah, but ln of 1 is 0. You get ln of 10 is equal to Let me see, you think this is the easiest unit?
I don't know if it's the easiest unit, but I know the drug's working pretty well. I'm just kidding.
Yes. Not right, you just choose whichever one you want to do.
He's a boss. Jacob's the boss today. Look at him go. He's like locked in.
Do the bottom one, because if you do that, then the top will be wrong. Yeah, because I said the.
I
just the extra.
I think you would have caught fish, like Paul.
Is there any combat from or just UCF not got anything?
UCF, I think the deadline for Spark is February 15th. And FSU, I think it's still up too.
You guys finish?
That secant squared x
Yeah.
over 10.
Over 10x.
They did. See, that's not easy to log. Because you're just gonna get into du over here. So then you just plug in you inject them all.
I should be able to tell. It is. It's all I have to tell you. One of anything else.
Apart from just like I should be things like stopping you from just writing it
What?
like apart from your work, is there anything that's just stopping you from just because you know that this is you just being like ln x plus x?
Yeah, there's a risk about that. Because sometimes, for example, let's say, so for example, like sometimes you do, sometimes like you say, oh yeah, that's just ln of 4x minus 1. Right.
Oh, but the 1/4.
Yeah, the 1/4 is there.
Okay.
So like for me, like just kind of do it to become second natural. Now in the future, when you get better from most of BC Cal, they can see it right away. It'll be 1/4 natural.
Yeah.
It just become a muscle memory because they already know that they done it so many times throughout a whole year, and they get repetitive thing. So like integration of sine of 2x would be like, oh yeah, 1/2 cosine of 2x, negative 1/2 cosine of 2x. And they can see that because they're still actually u equal to 2x. And then that's why it costs 1/2 in front, so they can see that more often when they get to BC.
The more you do it.
Yeah, and then but if you can see that and you want to risk that, that's your choice. I mean, for me, I'd rather do things the right way. So, for example, a lot of people think that SAT is very hard. No, SAT just focus on not making simple mistakes.
Yeah.
If you just answer the question, not making simple mistake, you can realize your SAT score also increases 40 to 50 points
Yeah.
without learning new things.
Mr.
Like-
J, can you scroll back down?
Like people just don't think about like, hey, this, they want to make sure that they want to do easy way. But When you do it so often, it becomes easy to you. You don't. That's the way I look at it. All right, so in this case, I would do u equal to x cubed plus x because you see this is 1 degree less for both terms. So that's du is equal to 3x squared plus 1 dx. And then this is the whole thing's a parenthesis. So be du over 3x squared plus 1 equal to dx. So that's going to be u and 3x squared plus 1. And then this is du over 3x squared plus 1. And they cancel out. So it'll be du over u. And it'll be natural log of x cubed plus x plus c. Now what Samuel just told me says, hey, is that possible? I just write down ln of x cubed plus x plus c without going through the du part. And I think that's a risky. And there's a reason why I feel like it's risky is because if you went back to look at this question, right? You say, oh yeah, that's gonna be x squared plus 1. Oh yeah, that's gonna be the derivative, it's gonna be x. But you forgot that there is a 1/2 in the front. You also could have forgot there's 1/4 in the front on this case if you don't do du. So it just much better if you just make sure you do the question right, even though just write down
What
extra
if,
2
like,
lines.
when we're writing the u and the du, when we find that, like, the du is the same as the numerator, can we just do that? Like,
You can do that. So in this case, let's say u equal to 10 of x, right?
yeah, and we know that the
Du equal to secant square of x dx. Yeah, this is gonna be replaced as a du over u. Yeah, of course. And that's gonna be ln of 10 of
So
x.
if there's like no coefficient, we can do that.
No, you can do anything you want. I don't want to restrict people doing. I just feel like just work it out. It doesn't. It becomes muscle memory. It doesn't take. It takes extra 2 seconds. It's gonna get right answer, which is a lot of time you make a simple mistake, right? And I make simple mistake because we tend to omit certain things. Now for me, I rather get an answer right, even I have to extra spend 2 seconds. Now some people think that 2 seconds worth the saving. So for example, competition, that yeah, you have to go fast. You cannot show all the stuff. Jacob, yes.
So for the first one, we don't actually have to take the logarithm. We just write ln of x to the third plus x.
Yeah.
Oh, never mind. I never.
But if I take the logarithm, will it be wrong?
Why you need to take a logarithm? Because right now we integrate this, and integrate du over u is just immediate becomes this.
Okay, yeah, I thought that I had to actually do the logarithm of u.
All right. So for this one, it's a little bit different. This one's u equal to x squared plus 2x. Now you see that du is equal to 2x plus 2 dx. It wasn't exactly same as x plus 1. But then you say, wait, that can make it exactly same if I factor out 2. And then du over 2 times x plus 1 dx. So that's going to be u in here is x plus 1, and this is du over 2 times x plus 1. Now you see this x plus 1 cancel out nicely, so it's going to be 1/2 integration du over u. Now you don't need to do, Jacob says, do I need, no, I hear just immediately natural log integration. So it's going to be 1/2 ln of x squared plus 2x plus c. And that's that. Okay, so for this one here is a little bit different. Now this one here is happened in, this one is a lot of people didn't know how to do it. Sepper supposed to know how to do this one though. Sepper, how do I do this one?
Not with you, but
Go on the board.
Come on, Sever, show us. Open it.
Huh?
Open it.
Just open it again.
Bro.
No, that's not.
That won't work.
Go on the board.
Yeah.
No, he doesn't know how to do it yet.
You set u equal to the numerator.
No, u equal to numerator, it doesn't work because it's only du over u. So
wait, is that cubed or squared?
square plus x plus 1
What's
over
the dividing thing called? The long division.
long division, yes. Okay, if, write down this statement here. Write down this statement. If numerator degree is the same or greater than denominator, then you do long divide. Okay, so how do I do long division? Most of you guys don't know how to do long division. Take the numerator.
Or greater than denominator.
Yeah, or greater than denominator. Then use the long division. Now, yeah, you'd say start like all those old math. Those old math still work. So what I'm saying is I'm gonna take the top part, put it inside, and this part I'm gonna put a placeholder because I see a degree of skipping. I feel that makes easier for me, but it's different. You can do it without it. I'm gonna plug in 1 because I want to get rid of x squared, so that's gonna be x squared plus 0x plus 1. And if you subtract them, this is how you get 0. If you subtract them, that's how you get x. If you subtract them, you're gonna get 0. So it's gonna be 1 and x. Now, how are you supposed to write this? This just becomes that 1 plus the x over x squared plus 1. Remainder over divisor. So that can be rewrite as 1 plus x over x squared plus 1. Now the numerator no longer have the same degree. Numerator has less degrees now.
Yeah.
Then you can just do natural log. Integration to x is going to be x. Integration 1 is going to be x. Now I'm just a big plus. Now I'm just going to do u simple u substitution. And then du over 2x equal to dx. So be x plus integration of u x. This is du over 2x. The x cancel out. So be x plus ln of x squared plus 1 plus c. So if the numerator has same degree or greater degrees, always long division. Now, is this question shown on AP exam? Yes, it did. And I remember which year is it, 2018 or 2017? Because the student come back to me, like 10 students coming to me, is like, Mr. Yan, you never teach this. I said, yeah, I did. This is long division. He said, oh. And a group of students said, yes, you did teach this. I said, yes, I always teach it with whatever technique you need to learn, and I will teach you. But this is one of the techniques that people don't remember. Is this okay? How much time I have? Huh? All right, so we got this one. Ooh, this one's a tough one. 10 minutes, I'll give you 3 minutes to do this one. Yeah, this will be very close to math competition level. This will be like 70% there. Remember all the old skill. Every skill matters. That's what the difference, like, it's really hard to teach math is because you have to have all the prior skills. You guys get stuck yet?
I think I figured it out. Let's just-
It requires another skill that you learned in the past. I say require the old skill in the past. Which skill I'm thinking of?
Can we get a hint?
Can I get a hint?
Yeah.
Well, I will tell you that this here had the same degree as this.
But we can make it the same degree.
Be 2x
We
plus
expand
0,
it. We
then divide.
No. Same degree, so require what?
On division.
But they're not the same degree. This is actually a second degree compared to here. This is first degree. So technically, first degree of the term. But if I were to do U substitution, if I do a U substitution, we require the U substitution, right? What do you think the U is? X plus 1, good. But the problem is X on the top, right? So what can you do?
Can't you do x plus 1 times x plus 1?
There you go.
I did that, but you don't get anything. It's still
Okay, so no, let's see. You got U equal to X plus 1, right?
yeah.
And then du equal to dx, which is really nice because that becomes u squared, and this is du, right? But there's 2x, right? Then you say, okay, well, here we're gonna pay attention. Says, well, they have the same degree, so we just have to get rid of x. And if I want to get rid of x, can I just say u minus 1 equal to x? So can I just say it's 2 times u minus 1 over u squared du? Now, since it's a constant, I'm moving outside. So that's going to be u over u minus 1 over u squared du. Now, it will require another old skill. This is where that this guy will say open up. What the hell does open up mean? Well, 4th grade math, right? Right?
Okay.
Split, right? So this one is u over u squared minus 1 over u squared du. So can I just change that to 1 over u minus u to the negative 2 du? Why I do that negative 2? Because the logarithm integration does not work to the second power. That just used normal power rule. Does that make sense? This is a power rule. This is a natural log. Because 1 over u squared, it does not equal to natural log of u squared. That's what people thought. But then you say, okay, well, that just means 2 ln of x plus 1, I think. And this one's going to be negative integration of 2 u to the negative 2 du. You can write down as 1 over u squared, but people are going to think that's natural log. That's not natural log. That's just normal power rule. So what's the integration u to the negative 2? U to the what? Negative 1 over negative 1, right? Minus 2, right?
Okay.
Let's get ln of x plus 1.
X plus.
Because this one is 1 over u. Integration of 1 over u du. See du here? I split to 2 parts, so I can say that's 2 integration of 1 over u minus 2 integration u to the negative 2 du. So this is du as well. So that's gonna be, yeah, du over u is ln of u. So now that's gonna be 2 ln of x plus 1 plus 2 1 over x plus 1 plus c. So 1 is u substitution, 1 is not.
Where did that negative 1 on the bottom?
Because integration of u to the negative 2 du is u to the negative 1 over negative 1. Because negative 2 plus 1 over negative 2 plus 1. How much time I have? Yeah, we can finish. The last one here is gonna be 1 over x ln of x dx.
For the answer, can you put the 2 on the numerator?
You can, of course. 2 is numerator if you wanna be. Yeah, it's actually better looking that way. Okay, this one's an interesting one. You have to you think about some of you guys like playing chess. You want to think about what's your next move, right? So every time I do u substitution, I think about what is du inside of my head. So I think about if I u equal to x ln of x, I'm gonna deal with product rule. It's like, that's gross, right? And then what do I do u equal to? Because if I say the du within the question, I can use immediately. So what would I use u equal to in this particular case? Good job. Why is it ln of x?
ln x.
Because this du is equal to 1 over x dx. Guess what? What is the 1 over x right here? Do you see that? Can I just becomes that this becomes then this one is going to be x du equal to dx. And then so can that just going to be 1 over u times 1 over x times dx, which is x du. The x cancel out, du over u. And that's equal to natural log of x plus c. I don't need a 2 absolute value. I just need natural log. So it's actually very, very clear, simple. So you gotta learn how to see du every time you do u. The rule of thumb, if you look at integration, always start thinking power rule. Okay, so when you start thinking power rule, if power rule doesn't work, can I split them? If it bottoms one term, can I split them? And I still can do power rule after that. Then if it doesn't work, then you say, okay, let's do u substitution. What do I do to u? U should equal to inside a parenthesis other than first power. But in this case, actually it can be the first power. So usually inside a parenthesis. Now, if a u substitution doesn't work, you should think about backsub. If they have the same degree, I will use backsub. Right? If numerator has a larger degree, then I will use long division. Denominator is 1 degree more than numerator, it's probably natural log. And then all the stuff. Yes. We learned that before.
Is that something that Brian or is that already solved?
Yeah, there is, but I'm gonna go over it when I go to e to the x. Cool. I forgot.
Yeah, not fair. A member of an online community of young men considers themselves unable to interact with
You too.
associated with those that are hostile toward women and men. Maybe like shut it or something.
Like, she's really obsessed with this. I saw you, I'm not gonna lie, I was
You are.
Like the merit-based system, that's kind of. All the systems. Or you can make integral from negative infinity to
Yeah, you
infinity.
can.
I'll go home and do it now.
Wait, did you already do UCS?
Okay, so
Who's there? Who's you did UCS?
what you could do.
You there?
You could do it.
Yeah, I'm scared about for Miss Kitty because she like something with our class name is wrong, so I'm
How was the
think
game?
I lied.
Bye, Vijay.
Come here.